Hey guys, welcome back to my YouTube channel. In this video, I'm going to discuss about indefinite integrals. Our objectives is to define indefinite integral, identify and distinguish the different properties of the indefinite integrals, and evaluate indefinite integrals. An antiderivative of function f of x is any function f of x such that f prime of x equals f of x for every value of x. The process of finding the antiderivative of a given function is called antidifferentiation or integration. For an example, let f of x equals 12x squared. Then f prime of x equals 24x equals f of x. So f of x equals 12x squared is the antiderivative of f of x equals 24x. The symbol denotes the operation of antidifferentiation, and we write this one, where f prime of x equals f of x and c is an arbitrary constant. This is read as the indefinite integral of f of x with respect to x is f of x plus c. In this notation, the symbol is called the integral symbol, f of x is called the integrand, dx is called the integration variable, f of x is the one antiderivative, and c is called the constant of integration. The following are the properties of indefinite integral, and we will discuss these properties one by one. The first property is the indefinite integral of dx is x plus c. The next property is the constant rule. The indefinite integral of k with respect to x is kx plus c, where k is a constant. Let's have an example. The indefinite integral of 5 dx. 5 here is our constant, so just simply put 5 outside the integral symbol, then dx. So our final answer will be 5x plus c. The next property is the power rule. For any real number n where n is not equal to -1, the indefinite integral of x raised to the power of n dx is 1 over n plus 1 times x raised to the power of n plus 1 plus c. Let's have an example. The indefinite integral of x raised to the power of 4 dx. 4 here is the value of n. So it will be 1 over 4 plus 1 times x raised to the power of 4 plus 1 plus c equals 1 over 5x raised to the power of 5 plus c. Simplify, so our answer will be x raised to the power of 5 over 5 plus c. Another example, the indefinite integral 3x raised to the power of 4 dx. In the second example, we have a constant which is 3. So we can apply the constant rule also. So let's put the 3 outside the integral symbol, then x raised to the power of 4 dx equals 3. Apply the power rule. 3 times 1 over 4 plus 1 times x raised to the power of 4 plus 1 plus c. So it equals to 3x raised to the power of 5 over 5 plus c. The next property is the indefinite integral of logarithmic function. The indefinite integral of 1 over x dx is ln absolute value of x plus c, where x is not equal to 0. Let's have an example. Number 1, the indefinite integral of x raised to the power of -1 dx. X raised to the power of -1 is also 1 over x. So the answer will be ln absolute value of x plus c. Example number 2, the indefinite integral of 4 over x dx. 4 here is a constant, so we should put it outside the integral symbol, then 1 over x dx, so it equals to 4 ln absolute value of x plus c. Next is the indefinite integral of exponential. So the first one is the indefinite integral of e raised to the power of x dx is e raised to the power of x plus c. The next one is the indefinite integral of e raised to the power of kx dx equals 1 over k times e raised to the power of kx plus c for any non-zero constant k. Let's have an example. Number 1, the indefinite integral of 9 e raised to the power of x dx. 9 here is a constant, so we should first put it outside the integral symbol, then the e raised to the power of x dx. Our final answer will be 9 e raised to the power of x plus c. Second example is the indefinite integral of e raised to the power of 9x dx. We can apply in item number 2, we can apply the second property above, since the exponent is in kx form. So that would be 1 over 9 times e raised to the power of 9x plus c. The next property is the indefinite integral of the sum and difference. The integral of a sum or difference of functions is the sum or difference of the individual integral. This rule can be extended to as many functions as we need. For an example, the indefinite integral of the quantity 3x plus 5 raised to the power of 2 dx. We should apply the FOIL method first, because since this is a polynomial. So we have here the indefinite integral of 9x squared plus 30x plus 25 dx. And we can apply the other property, the constant and the power rule for this expression. So we have here the integral of 9x cubed over 3 plus 30x squared over 2 plus 25x plus c. And we can simplify this one. So the final answer will be 3x cubed plus 15x squared plus 25x plus c. Another example, the indefinite integral of dx over x cubed. We can also write this as indefinite integral of x raised to the power of negative 3 dx. We can apply the power rule for this example. So we have x raised to the power of negative 3 plus 1 over negative 3 plus 1 plus c equals x raised to the power of negative 2 over negative 2 plus c. Simplify, so our final answer will be 1 over negative 2x squared plus c. And for the last property, we have here the indefinite integral of u, or the substitution rule. The indefinite integral of f of g of x times g prime of x dx is the indefinite integral of f of u du, where u equals g of x. Let's have an example. As you look at this example, it's kind of difficult than the previous examples. However, they aren't too bad once you see how to do them. Let's start with the first one, the indefinite integral of the quantity x raised to the power 4 minus 1 squared 4x cubed dx. In this example, we let u equals x raised to the power 4 minus 1 and compute the differential for this. We get du equals 4x cubed dx. Now let's go back to our integral and notice that we can eliminate every x that exists in the integral and write the integral completely in terms of u using both the definition of u and its differential. So we have the integral of u squared du. And now we can simplify it by applying the power rule. So 2 here is the value of n, so u cubed over 3 plus c, and substitute the value of u, so the quantity of x raised to the power 4 minus 1 cubed over 3 plus c is the final answer. Another example is the definite integral of square root of 1 plus x squared times 2x dx. Let u equals 1 plus x squared and compute the differential for this, so we get du equals 2x dx. And write the integral completely in terms of u using both the definition of u and its differential, so we have the indefinite integral of the square root of u du. And next, square root of u can also be written as u raised to the power of 1/2. So we can apply now the power rule. So u raised to the power of 1/2 plus 1 over 1/2 plus 1 plus c equals u raised to the power of 3/2 over 3/2 plus c. Our denominator is a fraction, so we can reciprocal it. So it will be 2u raised to the power of 3/2 over 3 plus c, and substitute the value of u, so it will be 2 raised to 2 times the quantity of 1 plus x squared raised to the power of 3/2 over 3 plus c is our final answer. I've prepared here an exercise. The direction is evaluate each of the following integrals. So that's it for our discussion about indefinite integrals. If you have any questions, clarification, and suggestions, kindly comment it down below.